All right, the second fundamental principle of mathematics is the fundamental principle of multiplication. So it states that factors are multiplied term by term in any order. So again, we'll go through what all this stuff means, but um, first of all, I want to just talk about what multiplication is. So multiplication represents repeated addition. So if I have 5 additions of 4, then this would be 5 times 4. Now, when I write this multiplication, we can get the total value by just multiplying 5 times 4 or adding up 4 fives. This would be 20. Um, so the way we write multiplication with numbers is 5, and then I like to use parentheses to represent those. So the 5 and the 4, the 5 and the 4 are factors, and the factors are just parts of multiplication. So the other thing I wanted to realize is that we can explain multiplication as a group. So this is a group of 5 fours. So let's look at the next problem and kind of talk about it as a group and then convert it to multiplication. So you notice I have 3 students plus 3 students plus 3. So I have basically 6 identical groups. I have 6 groups of 3 students. So if we think of multiplication, this would be 6 times the 3 students. So this would be equal to, if we wanted to get a total, this would be equal to 18 students. So everything is identical. The numbers represent the same thing. So we can use multiplication to represent that. So in the next example, we'll do the same thing. What happens if we have groups that are not alike? How do we represent it with multiplication? So this is the first part. I got apples and oranges and bananas. I'm adding these all up. Well, we could group the 3 apples together. So I have 3 apples. So maybe we could write 3 times apple to represent those 3 apples. So in math, if I look at the oranges, sorry, I'm adding 4 oranges. Well, we could put those 4 oranges together as 4 times oranges, or 4 oranges. And then finally, it looks like I got 2 bananas. So we could group that as 2 times banana, or 2 banana, right? So I'm actually adding then these things together. I could use multiplication for that. Well, in algebra, usually instead of the whole word, we just let one variable represent what the quantity is. So maybe we can call 3 apples just 3A. And then I'll add that to 4 oranges. Well, maybe that would be 4O. And I know that looks like 40, but O is not a very good letter to use in math. But and then we want to add 2 bananas, and maybe that would be 2B. But there are 3 different things. I can't add those expressions together, but I can at least use multiplication to represent the groupings. So the last thing is, what if we had 4 baskets of fruit? So if we had 4 baskets of fruit where each basket has 3 apples, 4 oranges, and 2 bananas. So the 3A plus 4O plus 2B actually represents the whole thing together represents 1 basket. So if I have 4 baskets, then I can just take and multiply that 4 times. So 4 baskets would be the same as 4 of these groupings of fruit. So if I look at this, how many apples then would I have? Well, if I have 4 baskets with 3 apples each, don't I take 4 times 3 to get 12 apples? And the same thing, don't I take, if I have 4 baskets and each basket has 4 oranges, I take 4 times 4 to get 16 oranges. And then 4 times 4, 4 baskets each with 2 bananas, I have 8 bananas. And this is our first idea of why distribution, we call this distribution, because I'm repeatingly the same groupings, the separate groupings, I'm repeating 4 times. Each of those fruit are going to be multiplied by 4. So that's the distribution property. And we actually use it when we multiply numbers um, in the procedure for multiplying numbers. But think about when we multiply numbers, we start vertically, 32, and then we multiply 21. And we start with a 1, and we multiply it times 2. And then we take the 1 and multiply it times 3. So 1 times 2, we take and drop the 2 in the same column. 1 times 3 is you just write the answers in the columns. But then you go to the next digit, 2, and when you multiply the 2 times 2, you have to move over, right? You either put a 0 here or move over 1 to start your answers. So 2 times 2 is 4, and then 2 times 3 is 6. So then everything's in columns, we just add them together, 672. So we might call this digit by digit multiplication. Okay, each digit gets multiplied by each digit. But why do we do that? And it's easier to think about this when you have the expanded form of these numbers. So 32 is 30 times 2. If you think about each of the digits representing a number, we take the first one was this 1, which is a ones place. We took the 1 and we multiplied it by the 2. And we got 1 times 2, which is 2. Then we took the 1 times the 3, or in this case, the 3 represents 30. So 1 plus 30 would be, or 1 times 30 would be 30. So when we took the 2 digit in the bottom and multiply, we had to move over 1 unit or 1 decimal place, right, or 1 place value. And the reason why is because that 2 really represents 20. So when I multiply 20 times 2, I get 40. And then the 6, I took the 20 times 30. Well, 20 times 30 would be 600. So these are all the values of the terms. And the reason why we put things in columns over here is so that we keep track of like digits. We need to keep track of like or the same digits, right? Well, if I have them expressed, I can now see the like terms, like numbers, right? And combine those. So I have a 600 here. Well, the 30 and the 40 are both 10, so I can combine those to 70 and then plus 2, which is the same as 672. So in a sense, multiplication becomes term by term. So instead of digit by digit, we call this term by term multiplication. Oops, I can't spell. Again, we'll cover this in the next section, but I just want to talk about then in all um, what the composition of mathematics is. So these fundamental principles of addition and multiplication must govern everything we do in mathematics and algebra. Therefore, all mathematics is defined by combining terms, and this was from the addition property, and multiplying factors. So those are really the only two things that we do in math. We combine terms and multiply factors in any order. So just for terminology, we call the terms and factors the components of mathematics. An expression in mathematics is any combination of terms and factors. So again, we're going to have to go through and define all this, but as long as I understand the makeup, then I'm only dealing with terms and factors. The composition of an expression is the makeup or physical structure of the expression as separate terms and factors. And again, this will be the first thing we learn in section 1.1.